I guess we'll start then. Is your mute still on?
I believe so. Yeah, because it was echoing.
Okay.
Yeah.
Wonderful.
I'm unmuted.
Beautiful.
That's good.
Oh, magic.
Ask and you shall receive. Within reason. Yeah, right. Also, the front door will not open. If not, we can leave that too.
Otherwise, how's the environment? How's the ambiance?
Nice.
Okay.
Excellent crowd. I said I would have all these people over.
So we're going to your house after. Love it. Hi everyone, thanks for coming. I'm Lauren Weston. I manage the Franklin County Natural Resources Conservation District. We helped get a grant to connect Montgomery with an engineering firm and to connect with all of you to really dive into this flood resilience study. And so very excited to turn it over to Jess and Alex momentarily. We just want to thank you all for being here. And this really is all about you. So interrupt, raise your hand, ask questions, yell at us. It sounds great. Sorry, I'm volunteering us for that. We can take it. But just very, very grateful for the turnout tonight. It's great to see so many faces. Do you want to
Oh, yeah. Alex is driving. I guess so.
There's one. Lights.
Yeah.
Beautiful. So some background on this project. We started applying for this project probably 2 years ago for funding and got some funding through the Flood Resilient Communities Fund through Vermont Department of Public Safety, and have had this full year or since January to really work on this project. We had a kickoff meeting in March, I believe, and since then have collected a lot of data that they'll get into, and now we're kind of at the feedback stage of what folks think is viable in terms of projects and what you guys are interested in pursuing. This is all completely voluntary. You don't have to do anything out of this, but as you probably have seen over the past couple of years, there's been a flood or two, and so trying to be a little bit more prepared as a community. Whatever you all decide to take on, we are more than happy to support. And just want to reiterate, the end product of this grant are some preliminary designs for some projects, but there will be nothing implemented because of this project at this time. However, whatever you want to move forward with, we'll get the funding to get installed. There's plenty of money out there for projects like these, so we're really excited to move forward with whatever you all want to move forward. This project started when the Montgomery Conservation Commission was connecting with some partners about the town land. That's why the wastewater treatment plant. Yes. And the well. That's what I was thinking. I think I had that backwards. Actually, the good water treatment plant, not the dirty water treatment plant. It's been a long summer. And really talking about what could happen at that land, and realizing that that land was in a really particular place in the watershed with so many confluences of different rivers, and wanting to explore what we could do for flood resilience there, and then really building it out to this whole kind of Montgomery-wide project. And so that's been really exciting and fun. And just really appreciated the support from Montgomery to do this work and whatever we decide to do to move forward. I do have a couple of note takers in the room too, so you might hear some click clacking and some pen writing, just so you know. And with that, I'll turn it over to these other ladies.
Thank you, Lauren. I'm just going to introduce myself because I'm going to talk a little later. I'm Jessica Luisos. I'm a water resource engineer. I work on rivers primarily. A lot of our job is helping communities evaluate flooding and then coming up with projects and actually working through the design, permitting, and construction process with communities. We also do a lot of river, floodplain, and wetland restoration type of projects as well. So a lot of water related stuff. And Alex and I work at a engineering company called SLR here in Vermont. We're in Waterbury. And I'm going to turn over to Alex, who's going to lead us through the first part of the presentation.
Thank you. My name is Alex Marcucci. I am a water resources scientist at SLR. I work with Jessica on all sorts of river-related projects, flood-related projects, as she described. So I'll be kind of describing the first part of our presentation, which goes over some of the work that we've done to date. And this is the second meeting kind of in a series of meetings, so we'll show a schedule in a minute. But there will be additional meetings to discuss kind of different phases of the project as we move through. So this is meeting 2 of 5, I believe. So thank you all for coming. Okay, so this is just kind of a brief overview of the project, and where we're at. So a lot of our work is kind of aimed at understanding the flooding. So we're building what's called a hydraulic model, where it's a computer model meant to model the river system, where we have a terrain and we put water in it and kind of test different scenarios and see if we can observe what flood patterns are happening in the watershed. And then from there, kind of coming up with project ideas and testing those out in the model to see which ideas might be most effective as far as flood reduction goes. So we've done the first few tasks that are listed on the slide, including our field data collection for the most part, and the existing conditions hydraulic model, which is meant to represent kind of as the river is currently flooding patterns. And then from there, we have an initial list of what we call alternatives or potential flood mitigation projects, which Jessica will talk about in a little bit. And following this meeting, we'll be kind of further developing those alternatives and eventually getting to concept design, where we're kind of preparing mini designs to move selected projects forward through the process. So here's just an overview of the schedule. We are at meeting number 2 right here in the beginning of August. So broken down, we've completed the existing conditions hydraulic modeling, as I mentioned, and from there we come into our alternatives analysis, where we're looking at these different potential projects that we've identified and moving from there into design and reporting as well. Meeting 3. Meeting 3 is going to be in October. Thank you. So just a quick overview of the area that we're talking about. So kind of looking at the Trout River from above South Main Street down to kind of just below Longley Bridge Road. So this is our whole focus area, and the green dots shown here are bridges. So I'll talk a little bit about the data that we collected. So we did have survey at these bridges. So we have survey data for the bridges, and we have additional data that we collected as well, but there's just an overview map. And we also wanted to include, these are the FEMA flood hazard zones as well. So the floodway 100-year, 500-year kind of shown throughout the project area, just to show existing floodplain mapping and regulatory capacity. So data collection, we have been out in the field collecting a lot of data on the river and the tributaries, kind of walking the study area, looking at channel dimensions, taking a closer look at bridges and culverts that we put into our model, making sure we have all the dimensions and materials and everything right in the model. So kind of step 1 is this data collection effort to inform our modeling and our analysis further on. What's also awesome about this project is we were able to leverage some UAS drone technologies. So we partnered up with Whiteout Solutions. They're out of the Northeast Kingdom. And we use drones to collect what's called topobathymetric LiDAR, it's a really awesome technology because it penetrates the water surface. So we're able to get a surface of the ground and the riverbed through the river corridor, kind of throughout the extent of our project area. And this shot is just kind of a shot of the point cloud that comes with it. So it captures tons and tons of points with different stratification layers. Like you can see the vegetation is green, the river is blue, the ground is brown. So it captures all these different what are called returns and kind of produces this 3D model, which we can then use in our river model. And the map that's shown on this slide just shows the extent of the drone survey that happened. And so as you can see, it's kind of a narrower swath right adjacent to the Trout River and some major tributaries as well. And just a few stats about the data that were collected. So 200 plus elevation points per square meter, which is just an enormous amount of data. And it's really, really accurate. So up to 3 centimeters of vertical accuracy. And then what's great is they also used kind of the ground survey data to inform their drone collection to make sure that it was extra accurate. So kind of using traditional ground survey as ground control points. And so this is a screenshot of our hydraulic model. And you can see here the model extent is shown in this polygon. And all of these blue and black lines show flow inputs. So this is our whole 2-dimensional hydraulic model. And we have a number of different locations where flow comes into the model. So that includes the Trout River, South Branch of the Trout River, Hannah Clark Brook, Black Falls Brook, West Hill Brook, and then a smaller tributary that comes in along Longley Bridge Road. And so the model, it encompasses about 7 square miles in size, and it's pretty big. There's over 250,000 what we call cells within the model, which are basically computation locations where the model is looking at water depth, water velocity kind of on a small scale that then informs the larger model as a whole. Another input that's really important for the modeling is we look at hydrology. So essentially we're looking at flows that we're putting into the model. So it's really important to have the ground that goes into the model, that ground surface, really accurate, but it's also important to have those kind of the amount of water that you're putting in also accurate. So we did a whole hydrology analysis where we looked at some nearby USGS gauges. There's also a gauge downstream on the Trout River that was only in operation for 2 years that we looked at as well. And then the numbers that ended up going into the model were from the FEMA flood insurance study, supplemented with regional regression equations. And those numbers, so what I showed before, the kind of model extent with those input locations where we're putting flow in, that's where all these numbers go in. And we looked at a number of different events. So kind of the 10-year flood, the 50-year flood, the 100-year flood, the 500-year flood. And rather than thinking of that as like a 1 in 100-year flood, it's more like a 1% chance that a flood like that could occur in a single year. And as we know, that's changing. Of course, our flood frequency is changing. So other things that kind of go into our hydraulic model, we use land cover. So this is high resolution land cover mapping that was done by UVM in 2016 as kind of a base, and that inputs what we call roughness values into the model that helps kind of calculate how water moves through the model. So that's just a little snippet there that shows different land cover types that went into the model. And so as I mentioned before, the base terrain, it's a combination of a couple different things. So we have statewide LiDAR data, which is just, it's a technology where kind of from airplanes, you can sense the ground surface. Forgive me if you already know this, but we have that data from 2017 and then supplemented that with our drone captured data from Whiteout Solutions in 2024. So what that was able to do is kind of detect changes within that river corridor and also to give us the topobathymetric data, which can see beneath the water surface, which traditional LiDAR, those sensors can't penetrate water. So we have really detailed mapping of the stream bed, which is quite impressive. If you kind of zoom in on the model, it's like amazing. You can see tons of little boulders and whatnot are captured by that. Another really important component of the model is making sure that we're capturing our bridges and culverts accurately. And that's where kind of that ground survey was also really important. So we have our ground surface and our water in the model, but we also have these structures, and looking at these structures and kind of flood patterns around the structures are also really important. So this example here is West Hill Brook, the North Main Street Bridge that's shown right in the center of that screenshot. So we have this kind of large model mesh that we refined to kind of capture our structures, our roads, any other features like berms, making sure it's aligned well to the river channel. And I think we have some videos. Yes. Okay, perfect. So we're kind of just going to show some examples from different levels of flooding that we ran through our existing conditions model. So this first video shows kind of a medium flood from upstream. This is Montgomery Center, and Montgomery is over here, how that flood kind of moves through the model. Is there a play button? I think it played on its own.
Huh. We'll play again.
Yeah, I'll press play again. So it starts dry, and then the model puts water in the upstream end, and it starts to flow through. And you can see as time passes, the water kind of comes out onto the floodplain. And then as our time period continues on, it starts to drain off the floodplain. There we go.
I'm sorry, is that a 100-year flood? Or what is it modeling?
Yeah, so, you know, we're going to refer to the 100-year flood as a medium flood. We know these are happening really often, and it's hard for us to say it's not going to happen for another 100 years. You've experienced floods bigger than that. You know, we think that the 97 flood was probably closer to a 500-year flood. So as Alex talks through this, the medium flood is the 100-year kind of hydrology, and the large flood is like similar to the 500-year hydrology. So, you know, just, you know, I think that the number makes it seem like it might not happen for 500 years, and that's hard for people. So we're going to just, for your reference, call it medium and large for just putting a less technical word on it, I guess.
Thank you.
Thank you.
So we pulled kind of consistently for our different model runs. We wanted to focus in both on Montgomery and on Montgomery Center, excuse me, the upstream village, and on Montgomery as well. So the small flood around a 50-year or so flood. This is just a screenshot showing those depth results. So it's water depth. The scale over here is 0 to 15 feet. As you can see, the main stem of the Trout River has the deepest water, and we see a little bit of water kind of spilling out into Montgomery Center under this kind of smaller flood scenario, and a bit more water in Montgomery kind of on the streets and around the houses as well. So medium flood scenario, again, it's the similar locations, just a bit more water in the model. And you can see kind of that location of water is just a little bit more coming up around the houses here, a little bit more across the road, as well as additional water in the village in Montgomery.
Is the town parcel in that screen? That is that one. Okay, I just wanted.
Yes, right.
Part of it.
Yeah. So this on the right here in the village of Montgomery, this is Black Falls Brook that comes down kind of from the north and joins up with Trout River here. Yeah. And then I should mention also in the left-hand portion of the slide, this is the south branch that joins in with the Trout River in Montgomery Center as well. And this is a video. Yep, this is a video as well. Okay. So for our medium flood scenario, and I'll turn off my laser pointer so I can play that again. This is the same thing we kind of looked at before, but zooming in a little bit to the village so we can kind of watch how the water moves as it comes into the model and see, you know, where there might be locations, if there's specific locations where floodwaters are kind of jumping out, if there's certain paths that floodwaters are taking through the village, to kind of identify where problem areas might be. And so I'll play that one more time just so we can look. You go from dry, no water, and then the water starts coming into the model. And this is Fuller Bridge right here. Actually, I'll put my laser pointer back on. This is Fuller Bridge, Fuller Covered Bridge right here. And we're kind of seeing throughout our model runs that this is an area where it seems like water is jumping out and kind of flowing down the roads and around houses as well.
Might be worth playing again. It's actually it's actually really interesting to see like the tributaries start to flood a little earlier. So you'll see it come in the tributary before there's much water in the main stem. And if people, we didn't, Lauren did say call out, but I mean, getting some feedback. If you're seeing something here where you really truly believe water does not get there or does, it'd be interesting to hear that feedback, because there's the possibility that maybe debris got caught somewhere and like pushed water into a spot where we're not seeing it, or maybe the terrain somehow actually isn't representing the ground. Like we feel like the terrain's pretty good, with the data collection we did, but so some feedback could be, we're happy to take that, if it seems like this isn't representing what you would expect or what makes sense to you.
Yeah, as the folks who live in the community, definitely, on the ground what happens. So let us know if you have specific thoughts kind of about what we're presenting. So we wanted to show, this is the profile of the Trout River throughout our model. And what's really interesting is you can see, a really dramatic change in slope. That's one thing that kind of jumps out right here. This is our upper reaches above Montgomery Center. We have this really steep, really confined river, a lot of bedrock. And then it kind of comes crashing down into Montgomery Center, where the slope drops quite a bit and our valley widens out. So that's one thing that you can see quite clearly in here. And another thing, the red shows the riverbed profile, and then the blue shows that 100-year or medium flood water surface elevation. So another thing that's really interesting that you can pick up on by looking at the flood profiles is areas where there's big drops in that water surface. So you can see kind of the call outs. A few bridges are called out on here as being kind of pinch points that are holding water back. And you can see that pretty clearly in the profile through these big drops here. So those are areas to look at, are these kind of bridges possibly causing issues with flooding? So it's just something to look at there. And we wanted to also just zoom in on definitely a dramatic example. So this is Black Falls Brook. We looked at the Trout River before, and this is Fuller Covered Bridge. And we kind of were looking at that when we were looking at the flow paths in that video, is that this is really holding back water, and water seems like it's kind of flowing around the bridge and through the village. Yes, question?
Oh, I was wondering, do you predict, like, in this medium or large flood that you're saying that these bridges are providing sort of a choke point? Do you think that the sort of like water levels or something would be enough that it would like damage or start to wash away the bridge instead of just like going out on the sides?
I think there's definitely that potential. And when we look at kind of both the water depth, and we also, through the modeling effort, we're able to see predicted water velocities as well. So looking at the combination of both of those things, you can kind of start to think about the structural integrity of around structures and of like stone embankments and whatnot. So it's definitely something that the model can inform. So as Jessica mentioned, we also looked at kind of a larger flood, potentially more like the flood of 97. And this one, I will play the video. This is in Montgomery Center. And as you can see, and we have some documented evidence from that flood where water, this is the old church, water kind of came out around the church and onto the street and around the homes and businesses here. So the video just kind of shows how that water comes and moves through the village. And once again, our side-by-side shots here, we have Montgomery Center and Montgomery with that large flood scenario. So a lot more of the village being shown as water flowing through, kind of leaving the channel upstream of the South Main Street Bridge here. And over on the right, in the vicinity of Black Falls Brook, again, just more water kind of flowing through the village in this scenario.
I thought in the 97 flood that bridge washed out. With the model show, it would wash out again, or maybe we could change the height of it, did we do something? I don't know.
Was it upside?
It's certainly different.
Yeah.
And we actually have at least one photo later on showing it, but it looks like not only the bridge washed out, but the river widened through there, and when you go back out today, there's walls and a new bridge that were put in. So I don't know exactly how much after it eroded wide they've put the walls back closer. So it's not clear exactly what it was in 97, but I do know that there was a lot of erosion and now it's kind of recontained, like until it either gets over the bridge or over the walls. So.
Yeah, we haven't modeled specifically. Like we don't have the old bridge dimensions from 97. So kind of what's in here now is the current bridge dimensions. So we can kind of, use all the information we do have about the flood and photos and kind of anecdotal information to inform what happened at that time and how that relates to what we're showing in the model. So an important part of building this hydraulic model is doing the work to validate the model as well. So we have this big river model, and we kind of touched on it a little bit, but taking evidence from past events and using those to kind of check the model and see, we have a photo of, in this case, this is Halloween 2019, where the water flowed out. This is West Hill Brook, flowed out over the road and back into the Trout River, and we kind of see that in the model happening. The water is going this way and over the road, and in the photo you can see that the water kind of came down the road and eroded North Main Street as well. So it's just kind of an example. We have a couple of examples of how we use historic events and historic information to kind of check our model and make sure, it's putting water where we've seen water in the past.
Can I ask a question?
Sure.
Looking here towards the village, it's always interested me that this is 2019, we went ahead and we built these new bridges, but we didn't elevate them anything from the past. It always seemed to me that we really needed a big arc over the whole thing.
Mm-hmm.
I happen to live on Black Falls, right in the village.
Mm-hmm.
And my whole thing is, why are we doing this? I mean, I think there was a plan that was probably put up in 2015 or whatever, and they follow through. We don't even have walkways that come down to one of our good play areas for kids. And many of us have children, don't particularly like to have them walk on this particular place because people go fast as well. So even though the intention was there, the dealing with the realities that we know already was somewhat bothersome, that we were right where we were. And like you say now with these bridges, maybe we've also had a discussion a few years ago about using a bridge we have in Storing and doing it on some kind of placement and use it for tourism. I mean, maybe what Montgomery should think about is kind of have a museum of its bridges, as opposed to, it's just gentlemen. I mean, if it's the flood block, it's kind of ironic, but anyway.
And this is an area Jessica will talk about in a little bit as kind of an area to look at for flood mitigation projects. We know this is a problem bridge. It's in a challenging location coming down from a really steep confined stream and then flattening out right here. And there's just a ton of sediment. And we know that debris also catches in the bridge and whatnot. So we'll talk more about that also when we talk about some alternatives. So some other spots where we've kind of checked the model to do model validation. This is Longley Bridge Road. And we know that water flows across this field and overtops the road kind of around the bridge, which is off here in the distance. So this is from Halloween 2019 after the water had already receded, and you can see kind of the flood water, the little bit that remains and sediment and whatnot. And so in the model, we do show water coming over the road in this location, kind of around the bridge as well. And some other things we can use when we're doing model validation is looking at, where has erosion happened? So this is Brook Road, and looking at kind of, we were talking about those channel velocities and the potential for erosion along the channel. So looking at where is velocity high and where have we seen these washouts before to help inform the model and how the model is performing and whether it's able to kind of predict these most vulnerable spots like on Brook Road where it's eroded in the past.
Does anyone have any questions on what Alex talked about? That was kind of our summary of the existing model, kind of what went into it, what we did so far, and some of the results. Because I'm going to jump into like some ideas that we can test to see if we can reduce some of the flooding and risk. So I just want to make sure if there are any questions about the model, this would be a good time. Okay, so yeah, go
I
ahead.
do have a question.
Yeah.
In the model, it's showing like the depth of the river in like 100-year medium or large. I was just down underneath that very bridge in the picture. The sand and rocks or silt is about 3 feet from the bridge.
Yep.
Well, if you had 15 on top of that, well, it's like, I can guarantee the bridge won't slide, nor any of the houses around it being limestone. But my thought is, in the picture, the river is, say 30 feet wide, when in actuality, half of the water is about 6 feet wide.
Yeah, you're referring to the bridge that's on West Hill Brook.
Right.
But I guess my main concern is, as the river swells, like it only gets up to my grass generally. Well, the leach field's not that far away. So when the water like resides, how clean is it?
Like, because it might be contaminated by the leach fields, you mean? Is that kind of part of the
Isn't that how it works? Like the soil gets saturated and then it takes whatever was in the soil with it? Isn't that why like the farms have to be so many feet away? I guess my thought is, if the river was a little deeper, would the water stay in?
So we're going to be looking at kind of a number of different alternatives in this location. And one option is including sediment management, because the bridge is really filled up. We were out there pretty recently. As you mentioned, there's only a few feet between that sediment and the bridge. So whether it's reconfiguring that structure into something that would be more suitable for this location, or developing some sort of management plan to kind of figure out, how best to pass the water through the bridge, because it's in a location where it's going to keep filling up with sediment.
Just after that, I'd probably say 25 trees. Like Mother Nature's version of a beaver dam. So, water goes up and pulls more stuff in the river.
Yeah, it's a really challenging setting to be building a bridge right at kind of the base of your watershed there, after you have that steep stream.
I guess a simple, not so simple, but what if we cut the dam apart, where all the trees fell into the river, so that the river doesn't necessarily swell over its banks?
like removing a debris jam in a certain spot, and that's certainly like a post-flood technique, like in spots where you get a lot of those, and it's pushing the river out of its banks. And I know that the town, like with various funding, did a lot of that after a lot of the past storms. So it is definitely a post-flood technique.
This area up behind the park, which is to the left in this photograph, that redirected by several hundred yards this fall. Is that reflected in here? I'm just curious to look at a
Over
close-up of
in,
where it would have been the Black Falls,
In
not
here.
no, further up out of the picture.
Mm-hmm.
Because Black Falls Road comes down,
Right here.
and first of all, to the right in your diagram, it's gouging at the road.
Mm-hmm.
When it comes up, it's digging at the road. There's boulders and all there. That's before the previous bridge, not this bridge, but the one in the distance in the photograph, not the west hill, but the Trout River Bridge.
Gotcha.
Before that,
it's
but when it came through,
I don't know if I have a good picture of it.
it's to the left of that photograph.
We could go.
Black Falls comes down
This is-
Yep.
It's
right
right
there,
here.
right there. where
It's
we
right
got-
here.
But then after it joins the Trout River again, right there, that came up and redirected
Yes.
over a peninsula,
Yep.
cut like
Yeah.
a 12 or 15-foot wide path.
Yep.
Yeah, it's
About
up,
this
it's right
deep.
here.
So
I
now
don't
the
know
whole
the
area
picture.
that used to be river is mosquito ponds and such. And if you walk these rivers, I think there are issues with regards to green and other color algae, the water temperature. Um, I don't know as we should be calling it the Trout River anymore. Maybe you should just call it river. But I think that there are ecological issues that need to be addressed as well. And I think changing the depth of it by dredging it or whatever you call it, as Chris is referring to, would help not only keeping it in its banks, but make it a healthier river for wildlife as well. Because temperature is, when water is like this, it's like a spa. We all know what those look like after a while without chlorine.
So
I
I
guess that was
think,
more of a comment than a
yeah,
question.
let's get to that after we go through the alternatives that we've thought of so far. Because I mean, I'm sure you might have some other ones, like in addition to making it deeper, that we can think about adding to the list. So in general, like what we've done so far is really try to look at these kinds of things listed on the screen, like spots where the river is really narrow. This is actually just a little snippet over here of the velocity map that Alex just showed. So this is Black Falls Brook, and the red areas are areas where the velocity is really high, and you would expect there to be erosion both down and side to side. And I know you have seen that in the past. There are some new locations of some riprap where it was really trying to wash out over here and over here. So looking for those constricted locations, narrow spots where maybe we've filled out into the river and it's kind of also constricting it and keeping it from kind of letting the floodwaters spread out. And looking at spots where there was damage to give us an idea of spots where there could be some work done or improvements. And then I guess one thing that we've seen in past floods, like, I think 2019 Halloween storm is like a really good example. Like when we got the list of projects that were done following the storm, it's a lot of putting riprap in a spot where it was eroding, putting road gravel back on the road in a spot where the water went over the road, like Longley Bridge, we had showed a photo of that. Removing debris, which makes sense. If you've got a bunch of trees or sediment like clogging up a bridge, it makes sense to remove that. So, the list of kind of flood recovery was very much of a kind of put things back the way they were in the past and kind of patch things up where it needed it. But at that point, there wasn't a lot of thinking about like, what are the things that we can do to prevent this from happening in the future or make it better or reduce the flood elevation, give locations where that sediment can like get out of the river and the trees can get out of the river and like settle out on the sides instead of getting stuck in the bridges. So what we're trying to do is kind of come up with some of those, I call them like big picture projects to like increase resiliency in the future. Like, so that's kind of what we're trying to do here. Not necessarily like fix a bit of erosion from after a flood, but like think about how we could try to prevent something like that in the future or make it a little less. And kind of big thinking. That's our goal. So with that in mind, Lauren started out the meeting by talking about this parcel here, which I think a lot of you are probably familiar with. We were told the address is 251 Fuller Bridge Road. So this is where Black Falls Brook comes down and meets the main stem here. With the idea being that this is a really great opportunity for thinking about how this could work better potentially with the river. Right now, there's kind of very narrow buffer, has a lot of knotweed in it, and there's a potential here to maybe take on some more floodwater and try to reduce velocities, like, someone just pointed out, there's a lot of erosion happening here where Black Falls Brook is very much pinched right against the road embankment. So, there is a lot of big armor on parts of it, but when you get to the end of the big armor, there's actually kind of a hole in the armor where there's erosion happening now. So, maybe if more water could get out onto this floodplain by, potentially like digging it down, and giving it more space for flooding, this could be like a nice flood relief area. So we call that kind of a project a floodplain restoration project, or sometimes if it's a wetter area, it could be a wetland restoration project, a spot where maybe it's reasonably high and dry right now, but could be brought lower and reconnected to the river to kind of let the water come out into that area, slow down, drop out sediment, and be a spot where trees could get stuck.
Excuse me, I have a
Yeah.
question. What does the dark blue line represent?
The dark blue line is the river center line. Approximately, it's an old one.
It's like the
Yeah,
state
well,
layer
that's what I was
from
gonna say.
many years
It's
ago.
it's a very old layer of where a long time ago someone thought the So the dark blue line is nice in the regard that in a spot where the aerial photo kind of hides the river, you can kind of see approximately where it is. It has these little labels on it. So you will see the dark blue line, but it's not exactly where your river is today.
Right, well,
Yeah.
this is what I was talking about.
Yeah.
Dredging.
Yeah, it goes through here.
Yes.
Yeah.
Dredging.
I am not talking about dredging. I'm talking about, you could maybe call it dredging the land next to the river is what I'm talking about here for floodplain restoration.
You mean for like, what, backwater? Creek spillway.
Yeah, so when the river starts to flood and like the wet part of the river gets full, it allows the water to go into a spot where you've chosen to send it. So it's kind of like
Relieve the pressure.
a
Yes.
safe overflow to relieve the pressure. The velocity usually gets a lot lower because there's less water kind of shooting down the channel. There's more of the water being outside in the vegetation. So that's an option here that we're going to look at. And we can look at various footprints. We know there's been some thinking at this spot already. Lauren had shared some of the initial thinking, as shown up here, that maybe there could be, maybe only the part closest to the river could get dug down and the other parts of the land maybe could be used for other things. So we'll, if there's feedback on this plan or if there's been more community thinking about like what this parcel might look like, we're open to that and can model different alternatives here to think about what this could look like.
I think this is a very good, strong place to focus on, not least of which it was donated to the town by a very generous local. It gave us a lot more land as well, and to have this as an opportunity, and I know I live right on the edge of it, is really kind of a gift.
The well itself was a gift.
Yeah.
Is the well shown on here?
It's up on the upper terrace. You go back.
Okay. Here. Sometimes this thing gets stuck. How did you get it off of there? Oh, that's interesting. Okay, I figured it out before somehow. So the little cursor's like stuck in my window. I can't get to the arrows. Okay, what if I use these arrows? I also can't use these arrows. We'll figure it out in a second, but we might be able to go back. Yeah.
In the model, I just don't have a good image of it. So when the pulse of water comes in, is this one of the first locations that is receiving floodwater anyway? You know what I mean? Is there sort of some kind of hierarchy that you assign? Like when you look at the pulse of water come in, it's like, okay, this place receives water first, second, third, you know what I mean? Some kind of, and I'm wondering where this falls in that timeline.
That is a good question. did not look at that specifically yet. So I guess this is a really good point. So we're going to throw some ideas at you, and we did not put them in the model yet. Like if you feel like something is a bad idea and you have different use for the land, or we might just not even look further at it. Or if you have specific thoughts on, hey, we could lower that whole area and it'd be fine, and we could still plant fruit trees. Like, if there's feedback like that. I do not know kind of how soon in the storm it floods already. Some water does get up here already, though.
This past season, it flooded several times.
It looked like from your
Really?
model that it was actually backing up
Really?
the tributary and accessing the fields that way, first before water was coming riverside and things.
Yeah. So that is part of what we can look
So
closer
the
at.
well is way up on top where that little building is, right?
You're
Go
right.
to your right.
Over here.
Yeah.
The well's right behind that building.
Okay, great, perfect. Okay, second alternative, this is the bridge where we were talking about West Hill Brook comes, in this case, it flows north and under Route 118.
And the town has gotten permits a couple times to clean out under the bridge, but within a year or two, it spills right back in.
Mm-hmm.
So that hasn't been working too well.
Yeah. Which is what we were realizing. I mean, you go out there right now, and I mean, this photo with all the gravels from, last month, just.
What's your recommendation for that area?
We are going to look at a couple different things. You did talk about bridge replacement. I know it's structurally a good bridge, but we can look at that. Overflow culverts. There are different management plans. I mean, one is just maybe you're doing the right thing by just, when it builds up, taking it back down. I don't know that that's the answer, but I think we're gonna be taking a closer look here. There are some ways of increasing sediment transport in areas by putting some weirs in. We're going to look at that, maybe just trying to have the water move a little quicker through this spot to be able to move some of it during floods. So we have some thoughts. We don't know what the answer is. And, if you have more information about how often you're cleaning it out, or, things maybe you've tried already, it'll help us kind of narrow in. I know, Stacy, you've done some work here. So specific thoughts on here would be helpful, because by standing there and looking at it, it's not super clear what the answer is.
I mean, we cleaned out just under the bridge, but we haven't gone down farther, so that's what happens. It starts building up again. Yeah.
Sure.
Was this study did it take into consideration where that debris is coming from all the time? I mean, it's gonna be creating some big holes upstream.
Yeah. This study is currently assuming that what's coming is going to continue to come. I think that there's a general recommendation to do additional work further up to see if there are specific locations that can be mitigated. So, we showed our kind of 7 square mile model area, because that's kind of the focus of this particular grant. I think it's pointing out that there are some spots where you're just getting a lot from upstream. And is there a way to now take this information and say, we really need to also now, as a second step, look up. Alternative 3 is maybe a little bit of a wild idea, but in this same location, maybe there's a way to turn the road so it moves over and meets up with Main Street further over, and creates like a wider location for more debris to kind of get to the bridge and kind of flow and sit over off to the side, just maybe giving a wider area here. So as that debris comes down, it can kind of spread out before it walks up the bridge and goes over the road. So I don't know before we model this if it's gonna do it or not, but it feels like a valid alternative. We had heard that there had been some homes here that were buyouts. So, this land, you're using it as a community garden right now, but if it seemed worth looking at.
Could be a rock garden.
It could be a rock. Yeah. So this was one other idea for this spot here.
But the ball field was flooded, right?
It floods in
The park in the
streets.
baseball.
Yeah.
Okay.
And as part of the bridge, we're going to see if we can get more water under the road too. I mean, maybe there's another way to do some overflow culverts or something else. So if the bridge itself would clog up, maybe there's another flow path. So there's a few different things we're going to look at here. Moving on. So Alex described a couple locations where the existing condition models showing that particular bridges are kind of backing up water upstream. Most of these bridges have had some damage in the past with erosion or water going around and causing erosion and debris kind of hitting the bridge itself and hurting it. So one of those is Comstock. Here's a picture of its location on the main stem, which kind of comes around, makes this turn before going under Main Street. So in these locations, I mean, we understand that these are like historic bridges and they're beautiful and they're a big part of your history. So although I have bridge replacement up there, and that's something I think we would look at just to see what it might look like if maybe that bridge was moved to a different location or moved off to the side. We're also going to look at overflow culverts, locations where maybe the road approach could be lowered to let water more safely kind of over and around. So at this location and some of the other, especially the historic bridges, we don't know what the answers are at each of these, but we're going to be taking like a closer look at what are the ways we can get water more safely with less damage, either under or around. So it's not.
There's also a big choke point in the right margin, like there's a canyon that travels through.
Mhm.
And I saw an old map, I don't know how accurate it is, which showed actually going across what is now 118 off the picture to the right to connect with Black Falls Brook. But that, at least this is the story that I heard, there was a lumber mill here, right about where your cursor is, and that they
Had
I
like
don't know
a
if they
flood
blocked
chute.
that off, but there used to be, I was told, a bridge at that intersection that's off the picture.
Oh,
And the
interesting.
water went that way, but they
Oh, right here.
rediverted or encouraged more of it perhaps to go this way because they had their wheels in that canyon to take advantage of the choke point there. So I don't know if how accurate that is. Again, it's an old written, drawn map from the 1800s, but
Yeah.
it does, if you look at it, it is much lower through there,
Mhm.
right by, again, Chris's house, right at that intersection there.
That sounds like a great idea. So, that's something I might describe as like a flood chute, like a location where there's maybe an alternative path for flow to go in during a flood.
I don't know how you
to-
do that nowadays, but
Well, we've certainly done it in other locations. We put one into Ripton is a good example on the east branch of the Middlebury River. So as water gets up, there's just another path for some of the higher flow to go in, so it's not going straight at the village.
Good with water to the town land too as well.
Yeah, so if water came across here, or off the page, I mean, we'll certainly look. It looks like maybe even here's an old path to get more water essentially from the main stem over.
Can I comment on that?
Yeah.
On that right-hand turn on Black Falls, In 1952, they brought in that highway and they changed the course of that river. Every time it floods, it jumps right there and goes back to the natural path. It also does it up by this gentleman's place. That river split and the flood, that river went right back where it originally was. There's two right-hand turns in the water. There's too much. The right-hand turn is so sharp, it goes over.
So did it used to come
See how
across?
okay, it came right down through there. Go,
Yep.
keep going to the left. No, a little
The
bit.
left. This
It
way.
came right, let me show you.
I'm really bad with left and right. No, it's.
Okay, the state that came down like this and went into black,
Oh.
like that. And now you've got this right-hand turn, it's too much. The same thing has happened right here. This bridge, this river was a Y, so it went through here, and there was a big swamp right there.
Yeah, so I think that's partly what you were talking about too. These are great suggestions, and I think that this kind of also piggybacks on cursor is what we were talking about on the last slide. I've never seen anything like this before. Oh, here we go. There it is. What we were talking about on this big parcel back here, if there are flow paths, at least this 90 degrees here seems like there could be some pressure taken off this 90 degrees with this land here.
Keep it away from the 118.
Yeah, so I think what you just described, maybe it's not going to be in its original path, but we could give it more space here, which seems great. So let's see.
But naturally they built up a speed calming situation in this road we put in here, just opened it up for more speed and also for big headaches. And I think that's a problem again. And then, like I live right on there, and it's the way it used to flow, zigging and zagging and stuff. It was maybe worked a heck of a lot better.
I mean, you could say that for the traffic and the river, both. It sounds like, I agree. So a ziggy-zaggy river is probably better than a straight one along your road. So different bridge, maybe a different situation, but kind of similar in that the bridge itself is like kind of narrow and water kind of goes around it. So looking at different alternatives at Vincent's Bridge, this is on the main stem, as well as Longley Bridge. We had looked at a photo of this before. Maybe, and I mean, these are things for feedback. If this is an acceptable situation to the town to just have some gravel to put back on, maybe we don't need to do a project here. Or maybe there is a solution to maybe concentrate the water or reinforce the road surface or something like that, so there's not as much kind of expected damage. Fuller covered bridge. This is one that Alex talked about and specifically showed on the profile, where you can see the river coming down and the water coming down, and then the water getting kind of stuck behind the bridge, just upstream. This is a tight spot, with roads with homes on both sides and the post office and homes downstream. So this is definitely a spot where if someone has an idea as to where you think the water could go, or if maybe one of these properties is for sale or someone's thinking about putting a property up for sale, and we could maybe come up with a spot where water could more safely get past this bridge. Maybe someone else has kind of an inside scoop on maybe how to get more water around. We're going to come up with some ideas, but if somebody has a thought, this is a particularly tight location.
You think it was filled in at some point, or made more narrow to put the bridge there?
I think so. That's what we think.
Isn't there land for sale up above that right now? Not anymore.
There are parcels, subdivided parcels recently that are between Black Falls Brook and, or between Brook Road and Green Mountain Drive, so.
So over
it's sort of
more up
open
here,
space,
yeah. So a little further from the river. I think here finding space like right next to the river, if possible, would be helpful.
It might be tough.
Yeah,
But
this might be tough.
couldn't you do some preventive maintenance by making, prior to having a flood, if the area upstream from that is deeper, then the debris that comes down during the flood doesn't fill up and block it and get stuck as much because it fills, sort of a hole.
Yeah,
But rather than just cleaning up the mess afterwards, maybe we need more preventive maintenance
so I'm gonna do a bunch
to
of
accept
flipping.
debris, stones, trees, etc., prior to these pinch points. Choke points, whatever you call them.
That's not a bad idea by any means, but I wanted to bring us back to, this is a spot where I know it just showed, so we have the water comes down, so the river's relatively smooth here. If the river had a really big bump here, that would be why the river might be kind of collecting things. What this is showing me is that the bridge itself, which is right here, the bridge itself during a flood is like slowing water down so much that in the moment, in the flood, it all gets so slow that anything that's in the channel coming down is just gonna stop, stop and drop. So I think even if you do spend a lot of time kind of digging this down, I think you're in such a backwater condition, you're probably going to have a lot of deposition during a flood.
Maybe that in combination with some other things.
Yeah, so it's not a bad thing. Like if you do have a lot of deposition there, maybe it is a location for some clean out, but I don't know that you could rely on that for the only thing here. Ooh, there it is.
Can I just, on the flood of 97, some of the first responders said at the Fuller Bridge, the water went through the bridge and over the top.
Top of the bridge.
Over the, and, because I.
The actual
questioned-
roof?
Oh, the floor.
Yes,
Oh.
yeah.
Not the roof, the floor.
The floor, over the floor. Okay, I was gonna say, whoa.
No, that it had gone through, actually through the bridge.
Which means that is causing blockage too. So even raising it a couple of feet could be,
Yeah.
again, with other things also, that might help.
Yeah, so I think there's potentially some options. Raise it, overflow culverts if we can find space,
Widen it to the degree you can.
widen it to the degree we can. So we're gonna be taking a closer look, but just knowing how tight the river is upstream, if anyone has an idea of a property for sale or something like that could widen it out, that could also be like a really big help. Stacy?
Jessica, this isn't right at the bridge, and obviously this would mean really working with landowners upstream. But where Black Falls kind of spins a little corner, Black Falls Road, yeah. If there were, again, kind of similar to your discussion on the other road, if there were opportunity for the road to be shifted away from the river, is there?
Predicting the future, Stacy. Yeah. No, keep going, Stacy. I like, this is, I think what you were maybe starting to get at. So where the river comes down here, it's really squished between, people living on the, this north side of the river, and the road is right here. This is a spot where it was washed out and there's some riprap put in. It's it's probably going to continue to be an erosion spot just based on the velocities. So I think what Stacy was getting at is, does this road need to be in this exact spot, or could the road move over further? And we just put this blue blob on here, but maybe the roads could come in up here and kind of travel closer to the tree line, and there could be more space for the river, like kind of dig down that land and let the river flood out into here. So like Stacy was saying, we don't know who owns this land or what the plans are for it, but it seems like a spot to look at least.
Yeah, that field is sold. Yes.
It was just sold. This is the one you said was just sold.
No, the name is sold.
Oh, the name. And then kind of similarly, is there an opportunity just right upstream of the bridge? I didn't circle any homes here, but I circled some of the open land and lawns. Maybe there's a way to just make the river a little wider here. Like we said, I don't know how much deeper we could necessarily go, but if maybe a little deeper and a little wider could help. And if there was another opportunity, like I said, if someone was moving or something, maybe this polygon could get even bigger, potentially. But this seems like a tough spot where, we really are seeing water coming out, damaging roads, getting into homes. So. Okay, totally jumping around. Did anyone have any other thoughts about those spots, Black Falls Brook or? Okay, totally new spot. So now moving up the Trout River, we were trying to look, this is just south of the center, across from the rec center. So this is the rec center here, an elementary school. This is a spot at the first meeting we had back in March. People were saying that the riverbank and the road bank are just kind of in a bad way here. The Trout River is flowing north here and comes around and is right against the road embankment. There's a lot of erosion. This is a spot where someone had put in some rock veins, a few rocks in the river to.
It was part of the original 1998 Trout River.
Yeah. And some of those are working really well, but they don't seem to go all the way down here. Those seem like they're maybe a little more upstream, maybe, or
parts have been buried, parts have been lost.
Yeah.
Been shuffled.
So some of them are definitely working. It seems like in this particular spot where it gets really close to the road, there could be some options, maybe for widening out the river to create a little more floodplain on the other side of the river, away from the road, just so instead of the river kind of coming up and hitting the road, it is starting to eat away at this side now. So there is some kind of just ongoing erosion.
Doing that for us.
Nature is doing some of that for you, but it's a much dirtier business.
That's all in the last year, what you see there.
Yeah,
That's
so
cut.
this is what it looks like now. So, or, last month. Another spot we saw, this is right downstream of the center so this is kind of as you're getting into the center. Here, also rec centers here. So this is a little upstream of there. So the river's coming this way and there's a giant boulder in the river. I don't know how many of you have walked back there. This is a spot where we don't know how much the boulder and all of the sediment bars is affecting things, but it is right downstream of many homes and businesses. It's a spot where the land of the valley is very narrow compared to the fields downstream and kind of up in the village. I guess it's a center. So we were thinking we could at least look there and see if there's an opportunity for opening that up. Maybe there's a sediment management plan, or maybe it doesn't affect anything at all and it's completely fine. But we're gonna take a look. Moving further upstream, in the center, there's homes and businesses that flood. You know, you've seen that in the past. The model's confirming it. So we were trying to figure out if there's ways to just give a little more space as the water's leaving the village, especially because we were seeing kind of the most flooding even at the smaller storms down in this area. So if there was a way to either kind of just open this up so there's more water adjacent to the river and less water up, where you're using the land. So we're going to test these. On the far side of the river here, it's really high. The land goes up quite a bit, so there's not a lot of opportunity here, and we know it already floods. So we're going to try this, but we do know it already floods, and there's not a lot of space on the far side.
There's also a lot of erosion on the banks there where the two branches meet. All the houses along River Street
Yeah.
have lost significant amount of property just through erosion over the last 10 years.
Yeah, right in here.
Yeah.
Yes, yeah. And, I know that this polygon here includes at least one home that's still there and some outbuildings and things. So there is an acknowledgement that, like, we're going to test this, and we don't even know if it'll work. But if it does work and it seems like it would be really worth it, then there would need to be discussion about, like, does it make sense? What are people using that land for right now? And what that might look like if it's even determined to be a good idea, which it might not help.
When you say test, what's the timeline that you're working with in terms of testing these options?
So we're going to come back in October and have another meeting like this with some results. But we thought it was important to, like, kind of show you what the model was and make sure you thought it was working properly, and, like, float these ideas. It would be, I don't know, I think it would be really hard for someone if they were the person who lives in this house here and there had been no thought or discussion about any of this, and you showed up at the meeting in October and it's totally out of the blue. So we're doing this first step of, like, talking about projects, and then we'll be back in October with some results. Okay, so this is just slightly upstream, the south branch and the main stem. A lot of this area is used for farming. It also a lot of it does flood already, so I don't know yet. We're going to take a closer look and see if there is an opportunity to kind of store more water there, or if it's already kind of storing as much water as it could. So that's one option. I think part of it is, there aren't a lot of options for where water can go other than into the home. So we're really trying to come up with ideas here. So one is the snowmobile bridge. We're not sure. The modeling actually isn't showing that the snowmobile bridge makes a big difference, but it could if it was clogged with debris. So we're going to do a little more looking there. It's right in the heart of the center, so we thought it was really worth taking a look at. Alex had shown some damage photos in the past, like when we were looking at the first part. Here's a few more. I think we addressed this a little bit. So the snowshoe had Main Street, had water. The bridge so this is the North Main Street Bridge. It was washed out. And I thought this was really interesting to me. So right downstream of the North Main Street Bridge, if you're looking downstream on the river left, this was all eroded down. Like, the river really used all of this area. And then if you walk through that spot today, there is this big wall here. So it seems as though following that 97 flood, some of this was kind of filled back in and a wall was put in.
Did the collapsed bridge help cause it?
It could
erosion
have.
there, and it looks like it's
Yeah.
tilted right this way to send more water.
There's also
Sideways.
erosion on the far side. So
Yeah.
on the far side, kind of in this upper photo, you can see there was erosion there.
Yeah.
And water went around the front of the snowshoe
Mhm.
also. So I think water was really going
Pretty
on
much
both
everywhere.
sides of the river
Down Main Street.
in this size flood. This is a really tough spot. Alex talked about the slope. Like we see a lot of damage in spots where there's that change in slope because your river is going really fast and it's coming into a spot typically with a lot of stuff in it, like rocks and trees. So this is a very tough spot to have a bridge to begin with, and then to have the walls and the buildings on both sides. It doesn't give a lot of space to take that. So I have this blue polygon here. Alex, I don't think likes this blue polygon because it includes homes and buildings and businesses in this polygon. And I don't know if we're going to be really actually talking about removing the things in this polygon, but we just wanted to think about like what could be done here. Could the flood walls be moved back? Maybe is there a strategic property where the building could be moved further from the river? If the bridge was bigger and had an overflow culvert. So we're just going to be thinking about this area, just knowing that water comes down and really goes on both sides of the river here in the modeling. So
Jess, is that area to the right where your cursor is, where it's like wooded, is that really steep in there?
Yeah.
Yeah.
It's pure rock.
Yeah.
It does flood. So I don't know if you remember, but some of the water was kind of coming out here and around also, because I think it's getting just backed up and then pushed. Good thought though.
Darn. Darn geography.
Is there as part of what you're doing, is there a warning system if we get, let's face it, some of the flooding that we see now makes all this look like a baby swimming pool. Okay, so if we get a monster flood, are we prepared also to tell people to get out of your house now and where to go? Have we focused on that at all? I think about that a lot in the center because at a certain level, there's no way to get out of the town. You can't go any way except maybe, you can head up to the cemetery, would be the best way. But as far as taking anything, so we are in a tight place if there is a big storm, and they're every place all over the planet now. So to have a safety system that, hell with your house, get your butt up here because your house is going, And so I was hoping there'd be some input on that. So people we talk about it in school, we talk about it with kids, about if we get this, that's just how you get out of it.
Yeah, it's a really good. So a lot of communities have used our models to then help come up with that plan. So like Jeffersonville, I think, is a really good example of that. We did a flood study like this in 2015, maybe, and they used that to like not only do a couple projects, which are helping things, but to also come up with that idea of like, this is when we need to have people getting out, and like, which are the people that need to, and it's a spot where there's been some of that work done. There was some help with, Stacy as one of the river scientists, as well as the Regional Planning Commission. So, Dean, this is maybe a spot where your group is Bethany here too, or so. That's like a collaborative process because it's really, really hard for a town to do that on their own. It's technical, but there's a lot of information in here that could kind of feed into that process, which I think could be really helpful. It's not a direct outcome. Like in November, we're not going to say this is the amount of rain where you need to leave your homes, but there's going to be a lot more information to help you come up with that.
Yeah, well, a lot of this stuff the community itself, I think, needs to anchor a lot of what it might do, because waiting around for FEMA now, have a gray beard in a lot of ways. And so the idea that community really should be exerting itself to a significant degree.
Yeah, we have an emergency plan. We
Yeah,
do not have a specific, like chapter for flooding. But your point is well taken. It might be wise to create one.
Yeah. Are you part of that process with the
Yes.
plan?
Emergency operations.
Well, it's good you're here.
I do a lot of traveling for work, and we have come to find that New England 511 seems to be the most accurate as far as where flooding is, warnings versus watches versus this road's closed, that road's closed. Generally speaking, I don't see Montgomery mentioned. I don't know if we don't fit into that category or what it is, but there's a lot of areas that are in worse shape than us that we can't actually get to. So it's like, okay, we'll go a different job. But that's currently the only way I know to find out what rivers are in what kind of shape.
So really, I don't know, does it do it up here? Cages. Nearish.
Some communities use the water prediction service from NOAA. They have kind of relatively real-time predictions for river gauges across the state, and we don't have any in this watershed, but there are some somewhat nearby that other communities kind of use to track storms, and sometimes those are somewhat accurate. Sometimes the predictions aren't accurate. It's a little bit of a difficult thing to predict because our rainfall is so localized, and it's hard to predict exactly the track of storms and which communities are going to get the most rain. But that is a tool that some communities do use, is the water prediction service, where you can see the hydrograph for the gauge that might be closest to the community and see what NOAA is predicting as far as like a rise in the hydrograph.
We're relatively speaking, we're very near the beginning of all these water sources. And it's not uncommon for us to see the river after a regular storm, rainstorm, go up 6 inches, a foot, and then be down again 12 hours later, and it's doing this all the time.
Yep.
So
Yeah, I want to
Is
cancel
there a
that.
process?
I've used the NOAA predictor and it's not super
Yeah.
accurate.
Yeah.
for drought.
Is there a process to appeal to NOAA to maybe install a gauge somewhere on the truck? Because right now, the closest one is at the Missisquoi down south of where the Troy meets it. So that's pretty useless for us.
There had been one on the trout for, was it 2 years?
Yeah, for 2
study?
years there
And
was.
that was really nice to have, and it's unfortunate that it got discontinued, but I
So-
don't know whether the.
I guess what I can speak to a little bit is we're working with other communities that are kind of trying to communicate with USGS that runs the gauges. Like Barry is an example. They're interested in having a gauge kind of installed in the center of the city there to inform their flood predictions. So yeah, it's something that I think can be on the table.
I don't know how much advance warning we get. I mean, where would we put it? In this picture. for
You're
instance.
right. It's a very flashy watershed. Absolutely.
We
So
can't put it
I
here.
was told when I moved in
Yeah.
that there's a white line on this rock on the right at the beginning of the Comstock Bridge. That when the water gets to that white line, that's when you get there.
that's when you gotta go.
I noticed when the water rises, I'm not the only one who knows that theory because they come and look.
Oh gosh.
Yeah, so everybody's looking at the rock. So there's also a gauge, there's a, like right next to the church. Alex is reminding me the technical term of the staff gauge, which I was gonna call it a big ruler.
It's a big ruler.
Because that's what you might think of. But there's a big ruler right here, and I don't know what that corresponds to versus like when your streets start
You'd
to
have to
flood.
take data and watch what happens on a half-inch rainstorm, a 1-inch rainstorm, a drizzle. I mean, after 3 days or 3 weeks of no rain, I mean, you'd have to take data for quite some time to know how to read and interpret the data that gives you. Before you can, if it goes up like this, do you blow the horn? Right? You can't
Yeah,
just put it in and react to it. You have to analyze data.
It's true, and there is a process for appealing to USGS to ask for them to put a gauge back in or to put one in the first place. So that is something that can be done.
Who initiates that? The would it be the select board would initiate it or?
I mean,
We can look into that and get back to you. Figure out if we can do it on your behalf or if we need the town to do it. We can it's on the list. Yeah. Honestly, it'll be good to know the process because a lot of communities in Franklin County probably use it.
yeah, and they have some really responsive staff who are very aware of these issues communities are having. So, you know, they'll at least be able to talk about like how it could potentially happen.
Do you model the difference between, say, an abrupt spring thaw and a severe storm in, say, August, like 1997, where the origin of the water is coming at a different pace from a different place? And I would imagine that it would manifest itself differently in a thaw, where we had like a double we have pretty much thawed all winter now, but if you had an abrupt thaw for a prolonged number of days after some heavy snow, you know, oh, how many month seasons did we have this year? 6. I don't know if it behaves differently in different times of the year, I guess is my question.
Kind of an impulse versus a long, steady.
Right, because you have in the spring, you're going to have elevated levels to begin with the normal thaw. And then if you have a heavy rainstorm on top of that, it's going to look differently than just because you're already starting from an elevated situation. That might be someplace where the data from a gauge could help us.
Because what shape did you
But
use for
again,
yours?
we'd have to
Did you
be
use the shape?
collecting the data.
From
That would
there?
have to be automated. Are these things automated?
So, do you want to do it?
Go ahead.
So I guess the answer is yes and no. So we have one assumption of general starting wetness and then what the shape of the hydrograph, like how much rain you get over the time in the storm is coming in each of the tributaries. So what is used, and I'm going to flip back a whole lot of slides here, back to where Alex talked about the hydrology. So the hydrology is basically what you're getting at, like how much rain is coming in from where and how fast. Mm-hmm. So the shape here, so this is the beginning of the storm, time 0, time 10 hours into the storm. So the peak of your storm is somewhere in the 2 to 5 hours after the rain kind of is coming in. This shape is from the Trout River river gauge from Irene. So that's the shape. You know, you only had 2 years of data, but somehow Tropical Storm Irene was one of the 2 years, which is very exciting. So we feel really quite good about the shape of this for that kind of large flood. And then each of the other tributaries, you can see there's not as much water in each of them, and the timing's a little bit different. So the way the model's set up is that there's some assumptions about initial water, kind of the amount of water kind of in the stream to begin with. And then this is kind of the storm that gets added on top of that. So the smaller tributaries are assumed to have smaller amount of water, and the water gets there faster. So we kind of saw that in the video for Black Falls Brooks, where you could see the flood coming in Black Falls Brook first before the main stem started to kind of flood out. So, I mean, you might have a time when you have a tributary that had extra amount of snow melt quicker and is different, but this is kind of the general model. You know, the tributaries generally have less water, generally get there a little bit sooner than the peak flow on the main stem. So we did make those assumptions, and we're modeling different size storms, but the timing and the shape of the storm is staying the same.
Seems pretty consistent.
Well, Irene was interesting because it came up, the Hudson, the whole thing came up the Hudson. We didn't even think we were gonna get it. And it came up and it, like I said, it clobbered us because I live right on there and we stacked all these rocks and stuff against the door. But once again, it's one of the advantage of being in the, it's right up here. It's a flash flood. So bang, we managed to keep the water out of the cellar for maybe only a foot deep for 45 minutes and it all went down again. But that's because it stopped raining.
Yeah.
And,
Other questions? I think I had just one more alternative. It kind of gets at the stuff coming down. We were trying to figure out if there was any spots where we could try to catch some of the water and debris before it got into town. Our model doesn't extend super far way up into the watershed, but one spot we were thinking is maybe some of these farm fields on the South Branch might help. Because it seems like the flooding in the center starts to happen kind of downstream of the confluence first. So, if there was a way to catch some of that water before it got to the confluence, maybe that would be helpful. And then here's just a summary of the ideas we just talked about so far in one spot. We're happy to take input, but there's also some of these other ideas that we're not going to be modeling because it's just not part of this type of study, the type of study where you're looking at the river model kind of around the villages. But I think there's opportunities for making sure there's buffers and woody vegetation. This catches logs coming down. When you have woody vegetation, it slows down water. Any upstream areas, trying to reduce sediment from road runoff. I know you've had a lot of road washouts at different storms, all that's just sediment that comes down in the rivers and gets clogged in the bridges. So, working on things like that. Generally upstream, if there's additional areas for flood storage, for some of that floodplain connection or wetland reconnection, that's more water that can be stored upstream instead of coming down. So, maybe looking more at river corridor plans or doing a second study after this one to really look at some upstream areas to target projects could be good. General stormwater mitigation, just less water getting into the river. And then what we didn't talk about, because this is very individual for individual properties, is there's a lot of other types of flood mitigation, which is specific to a building. So in the case where maybe your post office is a really important part of your community and you want it to stay there because it's critical for you. Maybe there's ways to actually work on the building itself. So when the water comes up around it, the building isn't damaged. So there's different ways of actually treating buildings. And we call that floodproofing, either to let the water go in and out safely or to keep the water from getting in. Or elevating of buildings and utilities. In the case where it really makes sense to stay, or they're really critical buildings for your community, there are some of these other techniques. Or in spots that are really risky and, someone can't sleep at night because they're worried about the next storm or they're so close to the river, buyouts are definitely, an option for locations like that. So in general, we are not going to be talking about specific buyouts and building elevations and things, but these are definitely things that go along with a study like this as additional options. And I think that was really it for today. So, we can definitely talk more if people have more ideas. They do really want us to look at on this list of things we're going to look at with the model. Let us know. And if there's feedback on the, kind of how we're predicting the flooding now, and if it matches or doesn't match what you would expect, also let us know.
We'll post this recording and these slides on the website we created for this, and I'll send it out in an email. You signed in with Dorothy. Dorothy's my raising hand. If you didn't sign in with Dorothy, I don't have your email address and I won't email it to you. But if you did sign in, I will send this out probably next week. but early next week.
Could we get some of those things available, like via PDF, so people could zoom into their, literally right in their house, right behind them and so forth to, because sometimes, well, first of all, as we pointed out, some things have changed and they're constantly changing, but also, it might help where your data indicates this, but the homeowner knows that it always does this also, or stuff like that. But if we have the ability for, we could maybe put them on the town website and get a link to them so people could zoom in and really study their own, the area that they know the most about.
Yeah. And Lauren, you're going to be posting the PDF on your website, do you think?
Yeah.
Yeah, so we can immediately give you everything that was in the slideshow today, and then maybe in the next week or so, we can put together some additional maps, because you're right, there are sections of the river we didn't show because we weren't, it didn't look like there were a lot of homes. It was maybe more agricultural fields. So we can show something that has kind of the whole extent too.
I will offer too, if you get this information and you have any questions, give me a call, shoot me an email. If I don't have the answer, I'll contact Jess and Alex, but we want your questions and your input. This is your project. So please ask.
Another question, sorry, I have a question, like when you said there's a lot of money available, like,
Yeah.
There's a lot of projects here that you all are interested in, I'm sure. But like how much, like, of these projects realistically, how far does that money go? I mean, I'm at West Hillbrook at the number 2 and number 3. So, I mean, obviously we're concerned about that. Like how much, how far does that money go?
Do you want to speak to this a little bit, or I can do my first shot?
I'll take 30 seconds.
Sounds great.
So I'm Dean from the Regional Planning Commission, and a hat I wear is as the staff for something called the Clean Water Service Provider. The Clean Water Service Provider was created by the state because EPA has said to the state, you have to help clean up Lake Champlain. You have to reduce the amount of phosphorus. There are councils, Warren is on them, and the councils make decisions on applications to spend money. The QUISP, the Clean Water Service Provider, for the Missisquoi Basin, for the entire Missisquoi Basin, and I don't have a map, but it's $1.5 million for what year one, and I'm just going to try to throw out a number. So it's $1.5 million for the whole basin, plus another $2 million for the whole basin, plus probably what'll be another $1.5 million for the whole basin. So like we have 3 years of funding that is assured, essentially, and we spend it on projects like this. Now, I don't know how much those projects are going to cost, but there's the beginnings of the information to start to estimate. And so when these ideas get sifted through and we figure out what the best ones are, the Clean Water Service Provider could receive an application from Lauren to start to refine the design. And then we start getting to talking about, this is more than 30 seconds, sorry. We start talking about, well, how much phosphorus will it remove or reduce? And that's the name of the game that we are in, is we want to fund projects that show that they reduce phosphorus. And just kind of roughly in a situation like this, think sediment, I guess, but the better the phosphorus cost effectiveness is, the more attractive the project is. And you've already got, maybe you can give the example of projects you've had funded and you remember the amounts of phosphorus better than I do. Maybe. You got a dam removal project, which I think is roughly 50 kilograms, and that was funded. So
Stacy is the expert.
I think, do you remember? Do you know? I don't know.
We'd have to look at our project.
So the issue isn't that there's no money to be found. The reason I'm here is to learn more about this effort. I knew this study had started because we're trying to find projects. Right now, we have more money than projects. So we want to fund projects. And I think when the system was created, there was this thought that there's going to be all this competition. Well, right now, there's not competition. And actually, another project that's been funded is one of Lindsay's, which is on Longley Bridge Road, not very far from where the town had to spend some of its own money and V-Trans money to deal with the situation there. But more projects like Lindsay's, more projects like this one could be funded by the clean water service provider. So we got 3 good years of funding. What's gonna happen after that, I don't know. But we haven't spent much of that money in the first year, and we haven't touched second year or third year. Hopefully that's assuring.
And that's one pot of money.
That's one pot.
There are lots and lots of pots of money. Obviously, some of the flood money is going through towns for repairs that have been hit. But I think Vermont's really waking up, and they know that they can spend money to prevent what's happening. So we're really good grant writers.
Thank you so much for engaging with town Montgomery.
Yeah.
This is so timely, because, I mean, I'm just worried about come December, what's gonna happen at the West Hillbrook Bridge. Because last December, it almost crested over, so. Snow melt and the rain on top of snow melt, so.
And I would love to say that there's plenty of money and it will work fast. The work fast part is not totally true, but we'll work diligently. It's safe money, so there's lots of hoops. There's so many hoops. But we're navigating them successfully, but it does take some time.
Excellent.
And I think to add to that, like the graybeard comment from earlier, like some of these funding sources are really, really slow. And we've seen communities kind of like picket projects, like maybe there's one at a time that kind of goes forward, or one to a FEMA funding source and one to what Dean just described that's more of a phosphorus related. Not all of these projects would qualify for Dean's funding source. So, but some might qualify for like a FEMA funding source because their kind of flood risk reduction is big enough. So I think Lauren's right, but it's like it kind of depends which project fits into which bucket and then what the timeline is for that. So
yeah, we're committed
and
to helping Montgomery.
Jessica mentioned Jeffersonville. I think Jeffersonville moved forward with 10 of their projects that have come out of the work successfully. They're, so it's been since 2015. But they have partnered with Clean Water Funding, FEMA funding, Hazard Mitigation funding, V-Trans funding, local funding. They fundraise to purchase a parcel that had been permitted to have a gas station put on it. Right? They saw the flooding in the community, said, "Oh, we don't want the gas station there." And so, it took active fundraising. So it is a mix of the projects, but we have seen communities successfully move forward with several projects. And they did see reductions in their flood risk and damages from these last storms because of those projects.
And I think the part of the story that's not necessarily only about money is also about the land and like how that process might work to say, okay, well, this farm is a spot where we could increase flood storage, but what does that mean for the people who are using that land right now? What does that look like? Is there a purchase? Who does that outreach? Is it someone from the town? Is it someone from the RPC, from Lauren's team? So there's definitely like a whole process. Like we can't necessarily like pick a project, do a concept design and like have it implemented in 6 months. Like it's probably a longer time frame, for at least a lot of these. So.
Probably have 3 floods before it gets done.
Not necessarily, no. Like so, like just to piggyback on what Stacy just said, like in Jeffersonville, they implemented 3 really big projects between Irene and the Halloween storm. So by the time the Halloween storm hit, like they were able to actually like stand out there and be like, wow, this is really helping, like, and see it. And like I was getting videos and phone calls about how excited they were that like it was working.
So your next step is additional modeling and making recommendations in October, correct?
Yes.
Do those recommendations come with an estimate of cost?
Well, October's gonna come fast, so I'm not gonna commit to cost estimates for 15 with multiple sub items, because it is a big effort, but we can have some like general ideas, like this is $1 million project, or this is a
That alone.
$100,000 project, like general range of scale. We can certainly do that. When we will have costs, so the idea in October is we're going to have a lot of information. We're going to talk about these 15 and maybe there's an A, B, and C on some of these if we came up with sub ideas. Some of these we might just like say it's not going to work and we just skip it. Like we don't spend a lot of time talking about it. But the idea is to try at that meeting to try to narrow down the list to 5 that we would really delve into and do a detailed cost. We would do some maps. We would, specify areas and volumes, and so it would be ready for like a grant application to move forward.
And if there's more than 5 good ideas, we can apply for more funding to move those other projects forward too. It just isn't in the current grant for this. Yeah, if there's stuff you guys want to do, let's do some stuff. I do think too, if your neighbors weren't here or you saw land that you know who owns that land, like we have no interest in blindsiding anyone. So if you want to approach your neighbors and just say, hey, and send them the website when I send it out next week and just really start the conversation. We want the conversation to be happening because, again, all these projects are voluntary. They're not land we own. They're land you guys own and your neighbors and community members own. And so nothing's going to get done if we don't have willing landowners. So we appreciate your help. It's kind of what I'm saying.
Yeah.
Has any towns downstream of Montgomery done similar studies? And because there's a lot of farm fields, downstream that could serve as flood mitigation areas, and obviously we can't do an eminent domain in Berkshire.
I'm not aware of something of this scale. I know when the scenic committee did a high level.
Yeah, just geomorphic though.
Yeah, and then there's some stream geomorphic assessments done, but it's not really like it's not this.
It's not modeling,
yeah. But your models indicate that our issues are happening here, not coming to us upstream. Right?
That's generally what we're
That's what I
seeing
saw
predominantly.
on those modeling.
So I think that's actually a really good point. So farm fields downstream are probably not gonna affect what's happening here. That's a good point. Fields upstream that could be modified could, because it would mean less water would get here.
Take longer to get here.
Anything else? I know it's late on a beautiful day.
I know.
Thank you very much.
Thank you.
Make sure you sign in and I'll be in touch.
We use the term village to refer to
Just the bill.